Hello and welcome to the second part of the assembly tutorial. Okay, in this part I will explain a bit how we use this app, this EasyCPU app. I will prepare a small example of an app. Okay, generally in programming we program a hello world app. In this case, we will just make a very simple, because for us to create hello world, you will see it's a bit more complicated, okay? But fine, let's start by explaining a bit how all this app works. You can either, today, I mean, when this app was created, there was no much of any kind of internet database where we can find or you could find instructions like we have today. Today we have Stack Overflow, we have Google, so today it may look easier to find solutions that we are looking for, right? But because of all the different kind of processors and some and changes in the hardware itself, we will see that maybe some of the commands we find in the internet may not work here. Okay, so to start with, I will show you the command option here that shows us which kind of commands we can use in our app. Okay, so if we decide to, for example, use any of these, you can just choose this one, and then it will help you, okay, to work around and create the command itself. Let's remember that for now you shouldn't be worried about this about this command, these details. I will explain it later. So, and you have to select the second one. You see, there is a small. Now you have to select the second one. You can see there is some bugs here. So, okay, so what we are doing here, okay, is writing us the command that will compare AH with AL registers. I will explain that now. After we finish explaining this part, I will explain what are each one of these screens. And if I put OK, it will add me this operation in the app, in the code itself. Okay, we have to remember that for now we are not going to touch anything up here or anything down here. Our code will be in here. These commands are the commands that load different stacks and different environment. It loads the environment and defines some information. So it prepares the registers that now I'm going to explain for us to work with here. Okay. Later on, we'll work more on those. Even we'll see what it means, each one of these. But for now, we're only going to work in here. Okay. So what all these panels mean? First of all, we have on the left side, yes, what we are called an input-output port. When we create an app, the app has to communicate with its environment, has to send some kind of information to its attached devices. And the only way to do it is by sending, in this case, a byte size of information. What is a byte size? Byte size is it's 8 bits, and a bit can be either on or off. So in this case, we have two ports in which the app can communicate. The first one is the ability for us to input an information into the app. And if we do this, what we can do is later on take this information and send it to the app. It's very similar to a keyboard. We have to remember that we are working on a very low level, and the only options that we have in our hands is to input and output 1 byte. And 1 byte can be, for example, translated into one letter. Okay. On the other hand, we have the second port, which is the output. The app can communicate to us a result, yeah, through these light bulbs, and the light bulbs will be on or off depending on the information in the byte format that it will try to send us. So for example, if you want to answer us with a Y, then the representation of the light bulbs will represent the letter Y in 8 bits, which is possible through an ASCII table that we will see later on. The CPU view here, yes, will represent in a very simplistic way how the CPU works. Inside the CPU, we have temporary registers, which are eventually today, in those times, there was a small cache size for the CPU, but today we have a bigger cache size and a bigger registers. Yes, here we only have 8 large registers. We have 4 registers with 8 segments of the registers. We have the higher side and lower side of 4 registers. Register A with higher side of the register, and registers A lower side. What does it mean? That means that we can use the registers. We can use those registers as independently, those pieces, or together. Okay, if our information is larger than 8 bytes, we can combine it with 8 bits. We combine it with another 8 bits and have in total 16 bits and represent that information here. Why it's so important? Because the registers are variables, are temporary variables that are going to hold and save information for us while we're doing operations. If you want to do, for example, multiply a number, we need somewhere to put the interim results so it can work. Okay. Here we will see which instruction the CPU is executing in each moment. Why it's so important? We have to remember that program languages are like a river flow. It flows in one direction, and it can be manipulated, but it will always go from start to finish. The energy in the computer comes in from one side and comes out in the other, and it changes the hardware structure, representing all kind of interaction with the user. For example, the screen and etc. So in the instruction register will show us each moment in which line we're executing, and that will be later on. We want to show it if it's in the code segment here. These ones, IP and SP, are flags. Okay, we will enter to those. We will explain this small because there are eventually more like registers that contain information. We'll show it later. Okay, what I want you to see more closely are these flags here. The flags here represent, the 3 flags here represent different values. In one side, it represents if the operation down here was 0 or not 0. We'll see it later, which is the 0 Z here, 0, which in this case is 0. If it's signed, if the operation that we executed here gave us a negative number, okay, and if we are using the compare process, that's this one. If one of those elements are true in our code, it will turn into a 1 here. You can always also put it by hand, and the reason is that later on you can execute line by line. We'll see it later. Here, of course, we have the code, as you know. The code segment. The code segment represents each line by line that will be executed, yeah, and it will be loaded here. We have to understand that program languages are turned into bytes, and those bytes are saved somewhere for later on execution. And in this case, the execution will be done line by line from up to bottom. The data segment is an array of information that we can manipulate and put and use to save more information, more than just the registers here. You have to remember that registers are very, very limited. We only have 8, well, in this case, 4 or 8. And if we want to save more information, and we want to use this as interim registers, we have to use this data segment to save more information so we don't lose it, okay? And the stack segment represents a memory use of stack, the memory stack segment, which eventually can, the app the processor uses to locate information resulting from all kinds of operations that are outside of our control. If we are not going to save information in the data segment, in the stack segment will be the app, the processor uses the stack segment as the support to save information in real time. And okay, this is all the elements that we're going to see here in the app. From now on, the next tutorial, we will explain how to start programming, how to start using this system to program the apps themselves.